Hello and welcome to Engineering Simple. In this video, I'll show how to calculate the capacitor bank rating, nominal versus actual, and also capacitor banks are made from units in parallel and a combination of parallel and series, and typically they're called cans. So probably you heard the terminology cans. So in general, you would have, like you have capacitor bank. So these are units that I'm showing here. It's like a can basically. And you have like multiple in parallel. Then you would have another set. So these are in parallel. So you have multiple. So dot dot dot. So you have multiple cans or units. So these here are in series. So let's call them number of units in series as NS, and these units here are in parallel. So let's call this number of units in parallel. So basically, this is, single phase. So this is single phase. So you'd have from here to here, basically line to neutral voltage, or yeah. So this is one phase. So you see one phase is made up from these cans in parallel. You can have as many as you need, and then you have these units here in series. So the nominal rating, or because capacitors, they provide VARs or reactive power. So the capacitor cap means capacitor. Single phase, so because these units here, parallel and series combination makes up single phase. So single phase is equal to the number of units in parallel times the number of units in series times the rating of the unit, the can basically. So basically this is a unit. It can be like a can, can basically. So notice the system voltage might be different from the capacitor bank, voltage. So the capacitor bank might be rated 1 voltage, but the system, it might be connected, when I say system, when it's connected to the power grid, it might be like 138, 145 kV or 161 kV and so on and so forth. And one thing I forgot to mention here, so the capacitor bank 3-phase rating basically is just 3 times the single phase rating. And I'll give an example which will make this clear. So if the system voltage where the capacitor bank will be installed is different from the rating the voltage rating of the capacitor bank, then the actual rating of this capacitor bank is equal to the rated or nominal rating times the voltage kV actual divided by kV rated quantity squared. And I'll give an example that will make it clear. Then after you calculate the rating, the capacitance is equal to the rating of the capacitor bank, so that's rated divided by omega times kV squared. Rated, this is rated. So omega is 2 pi times f, or frequency. Notice if you use Q, if you used the single phase rating, that means this kV here needs to be aligned to neutral. But if you used 3-phase rating, that means this here needs to be phase to phase or line to line. So notice these go along, and this here goes with this. So you need to be consistent in terms of units. So let's do a quick example. Let's assume we have number of units in series equal to 4 and number of units equal in parallel is equal to 11. So basically you have, and notice these capacitor banks, if they're small, they might be fused. So just for simplicity, I'm not showing the fuses. So you would have 11 of these cans basically. So just think there are 11 here. So I'm just going to skip. So these are in parallel. So just think the number here, that's NP is equal to 11. Obviously I have 4 in series, so these will be connected in series to another combination in parallel. So you will do basically 4 of these and they're connected in series. So I am not gonna, well, I'll just draw these. So dot dot dot, basically there are. Then you add another one. That's a capacitor bank. So dot dot dot. So the number of these units here is in series is equal to 4, and obviously this is connected. So that's one phase. So this here, these series and parallel combinations make single phase. So each unit, each can basically, so remember when I say unit, this is what I mean. So each unit is rated 400 kilovar, and the voltage is 23.8 kV, and the frequency is basically of the system is 60 hertz. So question 1, what is the three-phase rating of this capacitor bank. 2, what is the three-phase actual rating if this capacitor bank is connected to a 161 kV system. This is line to line or phase to phase. And 3, what is the capacitance? So 1, we want to find the three-phase rating of this capacitor bank. Again, so the single phase rating of this capacitor bank is the number of units in parallel times the units in series times the rating of each unit. So in parallel I have 11 cans times 4 times 400 kilovar. So if you carry out the calculation, you get 52,800 kilovar or 52.8 megavar. So that's single phase. If you want three phase, so you just do 3 times this is three phase. So three phase is equal to, then I'll have to multiply by 2. So 3 times that, 3 times that. So 2, we want to find the actual three-phase rating. Notice the rating of each unit is, so V unit is 23.8 kV. That means V single phase, it's the number of series, because the voltage will sum up, times V unit. So the number of series units in series is equal to 4 times 23.8 kV. So this is single phase or line to neutral voltage basically. So it comes to 95.2 kV, which is line to neutral. And so that's the rating of each single phase capacitor. And they're connected to 161 kV line to line. If you divide it by that by square root of 3, it will give you 92.96 kV line to neutral. So you see they're different. That means the rating of the capacitor bank will be, the actual will be different from the rated. So we'll use the formula for conversion from rated to actual. So three-phase actual is equal to Q3 phase rated times kV actual divided by kV rated quantity squared. So we found this to be 52,800 kilovar times the actual or the system voltage, which is 92.96 divided by the rated or the capacitor rated voltage, which is 95.2. So you have to be consistent. This is kV line to neutral. This is kV line to neutral. If you use the line to line, you have to use both quantity squared. And if you carry out the calculation, it comes to 50.34 kilovar. So that's how you calculate the, because the capacitor bank voltage is 92.96 kilovolt line to neutral, but it's connected to a system that's rated 95.2 kilovolt line to neutral. So 3, we want to calculate the value of C. So it's just Q rated divided by omega, which is 2 pi F times kV squared. So that's the rated voltage. So I'm going to use 3-phase kilovar. That means I have to use line to line. So omega is 2 pi times F, 60 hertz, times line to line voltage, which is 95.2 times square root of 3, because this is here is a line to neutral, times square root of 3 gives the line to line voltage. And if you carry out the calculation, this comes to 5.15 millifards or 5,154.1 microfarads. And if you want to calculate the impedance, X of C is 1 divided by 2 pi F times C, which is 1 divided by 2 pi times F, which is 60 hertz, times 5,154.1 times 10 to negative 6. So this comes to be 514.91 milliohms or 0.5149 ohms. Thank you and have a great time.